I just want to say one word to you. Are you listening? Microplastics. Starting in the 1950s, plastics got into everything. They were this wonder material, useful for its flexibility and flame resistance. Then gradually we started using them for convenience, for the experience of using them once and then throwing them away. But what happens to that plastic after then? Where does it go? In the 1960s, we began to find out. In today's video, a brief look at ocean microplastics. Mass industrial plastic production began in the 1930s with the first big wave of thermoplastics like polyvinyl chloride, or PVC, polystyrene, and nylon. The PVC material itself has actually been around since the mid-1800s, maybe even as early as the late 1700s. But it wasn't then useful. In its pure form, PVC is a hard and glassy resin with little use in industry. It was the 1930s era discovery of these special additives called plasticizers that turned PVC into a flexible, workable miracle material. These plastics' durability, insulation, and flame resistance drove wide adoption. PVC, for instance, began first with shock absorber seals and tank linings before spreading into flame-resistant coatings, raincoats, and shower curtains. Then, in the 1950s, the rise of single-use throwaway cutlery and packaging heralded a new type of consumption in the United States. These are made from a different thermoplastic called polystyrene. Life magazine famously ran a cover in 1955 titled Throwaway Living, heralding a golden age of time savings for the housewife thanks to these disposable items. Rising societal adoption drove global plastic production volumes. In 1950, the world produced 1.5 million tons of plastic. By the decade's end, that had grown to 5 million per year. It only went up from there. There have been reports of ocean trash or debris since time immemorial. Jules Verne's 1870 book, 20,000 Leagues Under the Sea, has a passage discussing how the ocean currents will bring together seaweed and shipwreck debris into patches. In 1947, there was a visual report of a seagull entangled in a 15-foot-long piece of string and chunk of wood, though it is not clear what that string was made of. So the first undisputed report of plastic trash in the ocean comes to us from the 1960s, thanks to a device called the Continuous Plankton Recorder. Dating back to the 1930s, the recorder is the world's longest-running marine biological recording program. Shaped like a metal torpedo, the CPR, as it's called, is towed by various ships crossing the Atlantic Ocean. Its job is to measure plankton in the ocean. Significant events like entanglement are recorded. In 1957, the recorder got entangled in what is described as trawl twine off the east coast of Iceland. This twine might have been made from natural fibers, but plastic nets were coming into vogue then. In 1965, the recorder was logged to be entangled in a plastic bag-like thing off the coast of northwest Ireland, often cited as the first instance of ocean plastic pollution. More plastic entanglements have been recorded in the years thereafter. Also, near the end of this decade, we get the first published observations of seabirds eating plastic trinkets like bottle caps, alongside natural stuff like floating pumice rocks. As global plastic production scaled up in the 1970s, scientists start finding more of it in the ocean. In 1971, J.B. Buchanan of the Dove Marine Laboratory in the United Kingdom makes the first widely published report of tiny plastics in the ocean. During a routine inspection of suspended matter in the waters off the South Northumberland coast, he comes across synthetic fibers. These fibers are colored red, blue, and orange, and found at all depths. Buchanan concludes that these fibers must be from fishing nets, citing prior records of natural net fibers in the literature. But those fibers were made from tree stuff like manila or jute and are expected to go away. The synthetic stuff seemed different. He wrote, The synthetic fibers, however, create a more serious problem. And apart from mechanical breakdown, it seems probable that they may constitute a growing and cumulative constituent of low specific gravity material in the suspended matter of inshore marine areas. That same year, Kenneth Smith and Edward J. Carpenter of the Woods Hole Oceanographic Institute are studying ocean communities of brown algae called sargassum in what is called the Sargasso Sea in the Atlantic. During this, Carpenter recalled towing a special net called a Houston net. You run it alongside a boat and it captures organisms from the ocean's surface. After a few runs, he realizes that the nets were pulling up a lot of plastic particles, about 0.25 to 0.5 centimeters in diameter. This plastic was brittle, indicating that its plasticizers, the aforementioned chemical that made thermoplastics flexible, had leached away. Carpenter recalled being confused because the Sargasso Sea was quite far from land. Where did these small plastics come from? Dumped waste from cities, fishing boats, or passenger boats, perhaps? They were not sure. So, he and Smith write up their findings and publish it in the magazine Science in 1972, and in their abstract they write, increasing production of plastics combined with present waste disposal practices will undoubtedly lead to increases in the concentration of these particles. The paper got written up in the New York Times, which noted some of the possible risks. One risk being that the plastics might release polychlorinated biphenyl, or PCBs, a known carcinogen, into the water. Despite this, nobody really cared. Carpenter recalled a few senior scientists at Woods Hole advising him to just, quote, stick to biology, end quote. A member of the plastics industry in Michigan gave him some grief over the paper. A little while later, Carpenter is studying plankton in cooling water from a nuclear power plant in eastern Connecticut. He later says, I squeezed with forceps what I thought was a fish egg, and it flew out of the petri dish and dropped on the table. I found that this was a clear polystyrene sphere, and that they were very abundant. These spheres were identified as polystyrene suspension beads. Plastic manufacturers do not produce plastics in their final shape, but rather in pellets sold to fabricators for final shaping. Carpenter continued, When I got back to Woods Hole, I threw my plankton net off the village drawbridge to catch the outgoing tide. To my amazement, when I held up the cod end, I could see the same polystyrene spheres drifting with the plankton. He then writes a second paper about this discovery, noting that fish might swallow and choke on these beads. Carpenter's two papers, in 1972, are by no means the first to discuss ocean microplastics, but them showing up in Science magazine brought greater attention, historically speaking. Throughout the rest of the 1970s, an increasing number of publications were noting small plastic particles in ocean water. A 1973 report from the National Oceanic and Atmospheric Association counted 24,000 plastic items washing up on 60 miles of Alaskan shores. Scientists at the time were surprised because these areas were not heavily populated at all. Then in 1974, another paper in Science confirmed the presence of plastic particles across wide areas of the North Atlantic. 50 to 69% of samples taken up by various ships in the area found them to contain the same polystyrene spheres, cylinders, and discs. And it was more than just the United States. A 1972-1976 survey in New Zealand discovered the same plastic pellets and granules washing up on their beaches. Despite this, concerns about ocean plastic pollution remained small throughout the 1970s. Nothing like when news of other pollutants like DDT or PCBs first emerged, which immediately generated an explosion of publicity and research. Yes, there certainly was concern about plastic debris entangling and choking sea animals, seagulls, turtles, and the like, but that seemed to be about the extent of it. Carpenter himself realized that plastics ocean pollution did not convey a viable future of research, and eventually went back to studying marine bacteria. Many years later, he mused that the public did not pay as much attention to plastic particle pollution in the water because, 1. The public mistakenly thought that all plastics were being recycled, when in reality less than 10% were. And 2, he cited a public misconception that all this plastic was coming from dumping into the ocean by fishing boats or container ships. Efforts thus began to ban those practices. In 1972, there was the International Convention on the Prevention of Marine Pollution by Dumping of Wastes and Other Matter, London. It banned the dumping of synthetic plastics into the ocean. Some 80 countries have ratified the convention, and such things gave an impression that a solution was being put into place about this plastic problem. I might add one more thing: uncertainty. Scientists could not positively say that these plastic particles were, quote, something to worry about, end quote, as one newspaper article put it. It was there, but was it a human health problem? This nobody could say for sure then. And lastly, the ocean is large and deep. The plastic was literally out of sight and thus out of mind, and pellets on the beach did not quite capture the minds of the public. Nothing like oil-covered birds or baby seals. By the late 1970s, published papers have observed industrial plastic pellets on the beaches of Canada, Bermuda, Lebanon, and Spain, and it was clear that this plastic debris was global. It was also clear that animals like seabirds were eating them, creating concerns about possible toxic effects or intestinal blockages down the line. In 1982, concerns about the impacts of plastic waste on the marine ecosystem eventually caused the Marine Mammal Commission to approach the U.S. National Marine Fisheries Service about arranging a workshop. So, in late November 1984, we had the workshop on the fate and impact of marine debris in Hawaii. Attended by 125 people from 8 countries, the workshop invited researchers to share notes on where the debris was coming from, its impact on marine resources, and what was going to happen to it. The workshop concluded that the marine debris was in all of the world's oceans, though nobody knows the extent of it, and that it presented a threat to marine animals like seals and turtles either via entanglement or consumption. Some positives were mentioned, like the fact that debris can offer shelter to fish. And there was a potential threat to human safety, but uncertain how so. Finally, they recommended a few basic things like regulating the disposal of plastic goods so that they do not end up in the sea, the use of more biodegradable material in fishing gear, and mandating more recycling of fish nets. This 1984 workshop went off so well that other symposiums and conferences were organized in 1986 and 1989. As these got larger and more information was shared, people began to grasp the magnitude of the issue. The late 1980s and 1990s see growing awareness of the plastics problem for the environment. The media blared out images of sad seabirds with plastic rings around their necks, or told of turtles eating plastic bags and starving. These motivated work to stem the flow of plastic into the sea. Another point that struck a chord with the public was the possible toxic effects. Plastics are often made with proven toxic chemicals like PCBs or heavy metals, and when they degrade in the ocean, they might start releasing those chemicals. In the mid-1980s, nonprofits and volunteer groups start to get involved, arranging cleanups to get plastic off the beaches. You had things like the Adopt the Beach program in Texas, or recycling stations in Alaska for handling nets. And then in late 1988, MARPOL Annex 5 came into effect. It restricted the dumping of garbage, plastics, and other synthetic materials like ropes, fishing nets, and plastic bags, with limited exceptions like in the case of safety. And then there was the plastics industry itself, which was largely left to self-regulation. During the late 1980s, they encouraged measures like voluntary industry recycling commitments and the Resin Identification Code, a triangular-ish looking symbol meant to help recyclers sort goods, but often ended up confusing the public about what can be recycled. It should be acknowledged that things did change. Researchers found fewer industrial plastic pellets in the stomachs of birds in the 1990s, but the total amount remained elevated as those industrials were replaced by consumer plastics like disposable cutlery and packaging. The microplastic concept, a small fragment of plastic, has been around since the very beginning, but we do not start calling these microplastics until 2004, when the term became popularized in a paper titled Lost at Sea, Where is All the Plastic? By Richard Thompson and others at the University of Plymouth. Thompson's short paper defined the microplastic term as plastic debris less than 20 micrometers large. It postulates that these plastics come from degradation of, or fragmentation from, larger pieces. It also highlighted their growing prevalence in nature using sediment analyses in the United Kingdom as well as plankton samples dating back to the 1960s. They also introduced these microplastics to a tank of barnacles, lugworms, and other detritus feeders. Those animals ate up the microplastics within a week, showing that these can indeed enter the food chain. Prior to 2004, microplastics' existence had been noted in studies and samples, but people paid more attention to the large fragments because of their perceived threat to wildlife. Few considered that these large plastic pieces might break apart into millions of tiny pieces, and even if they did, they probably believed that these microplastics were too small for any concern. Thompson's paper showed otherwise. The paper caught people's attention, and a spokesman for the American Plastics Council put the blame on improper disposal methods, saying, "You can't point your finger at one type of material. We all share the responsibility for keeping stuff from going into the ocean." In 2008, the NOAA sponsored another international workshop to figure out whether microplastics are a problem. The workshop formally defined the term to mean plastic fragments smaller than 5 millimeters large. People afterwards have also advocated for new categorizations in the future for yet smaller fragments like nanoplastics, which are less than 50 micrometers large. The 2008 workshop participants recognized that little research had been done and large knowledge gaps remained, in part due to the lack of good methods to collect, isolate, and quantify the microplastics themselves. Over the next 10 or so years, substantial work has been done to demonstrate just how widespread these particles are in our environment and food supply, and a number of things have been concluded. First, there are a stunning amount of microplastics, particle count-wise. A 2015 paper estimated that there were about 15 to 51 trillion microplastic particles in the surface of the sea, weighing between 93,000 to 236,000 tons. A more recent estimate from 2023 has updated the number to 82 to 358 trillion plastic particles weighing 1.1 to 4.9 million tons in 2019. Their cumulative weight is not significant compared to larger pieces of plastic, but the particle count is astounding. Second, these particles have gotten absolutely everywhere. They are on the shorelines, sediments of the deep sea, sea ice, rivers, lakes, streams, soils, and the atmosphere. They are drifting in the air and falling in the rains. There was even one report of finding microplastics at the top of Mount Everest. Third, animals eat these, leading them to accumulate inside their bodies. Microplastics have been found in over 1,300 aquatic and terrestrial species ranging from fish to birds to animals. Considering how ubiquitous it is, human exposure to microplastics, particularly in the food supply chain, is unavoidable. One 2020 study found around 50,000 to 200,000 microplastic particles under 10 micrometers large on fruits and vegetables. Another found tens of thousands of particles in the fillets of Mediterranean fish. So here comes the part about microplastics and human health. Before we continue, I want to say that I am not a doctor, and I want to give a measured take on this. It is known that microplastics are everywhere. Researchers have also demonstrated possible ways in which microplastics can cause harm. For example, a well-known 2013 paper showed that fish that eat large amounts of microplastics can accumulate toxins like PCBs, DDT, or trace metals in their bodies until they get liver or tissue damage. It is widely acknowledged, and has been for a long time now, that the same can happen to people. Microplastics can absorb toxins from the environment and then release them inside a person, though how much we are not sure. There are also various studies that show that particles can cause inflammation inside animal test subjects and laboratory human cell lines. But studies showing actual harm to humans have been few and far between. The microplastic term is a catch-all and covers a wide variety of things. Some degrade in less than a year or get broken down by gut bacteria. Others might last forever, some might be toxic, some might not. Just finding them might not mean much. And there is the standard thing that correlation is not causation. Massive confounding factors like wealth and health habits exist. And also, we are not very good at detecting these micro or nanoplastics. There was one landmark study that got a lot of attention, recently published in the New England Journal of Medicine in 2024. It enrolled 304 patients doing surgery to remove plaques from their hearts. Those patients with microplastics in those plaques suffered higher risks of stroke, heart attacks, or death in the 33 months thereafter. And just for you guys out there, I want to shout out this 2024 study showing that people and dogs with PVC and PET microplastics in their balls tend to have lower sperm counts than their peers. Something to ponder. Estimates are hard to come by, but it is said that each year 11 million tons of plastic enters the ocean. Roughly speaking, that is one garbage truck of plastic being dumped into the ocean each minute. The globe now produces about 300 million tons of plastic each year, and considering less than 10% of that gets recycled, the vast majority will end up in the ocean. Even if we somehow manage to stop it all today, there still remains an estimated 75 to 200 million tons of plastic left in the ocean. Methods do exist for removing microplastics from water. Filtration methods in wastewater seem to work pretty well, and there are some interesting methods that use green algae or chemical aggregate to collect them. But we cannot filter the oceans, and we still do not really know where on Earth all these plastics are ending up. They have to be somewhere, we just are not sure where. I still think efforts are worth it. I still think we should be cleaning up the oceans of large macroplastics, and I still think that we should be cutting down on our use of single-use disposable plastics. But even so, I fear that the microplastic problem has become so large that it is now practically unsolvable. Alright everyone, that's it for tonight. Thanks for watching. Subscribe to the channel, sign up for the Patreon, and I'll see you guys next time.